This is ChainMind, the decentralized AI network built for everyone. Just search ChainMind on Google, sign up, download the app, and you're in. That's it. You've joined the network. Run it on any device, phone, laptop, or server. Why ChainMind? Fully decentralized, fully yours.
When a single AI lab suddenly posts a $65 billion annualized revenue figure, the whole industry stops and takes notice. What makes that number even more astonishing is that it didn't appear out of thin air. It was built on a cascade of enterprise contracts, clever pricing, and a network of partnerships that turned a research-focused startup into a cash-generating powerhouse almost overnight. The story behind Anthropic's meteoric rise is a perfect case study for anyone watching the AI economy evolve, and it also shines a bright light on an emerging counter-trend that most people still overlook: the rise of decentralized inference. In the next few minutes, we'll walk through the exact drivers of Anthropic's revenue explosion, explore why the timing was right, examine what this means for the tug-of-war between centralized and distributed AI services, and finally see how ChainMind is positioned to be the bridge that lets the two worlds work together. By the end, you'll understand not just why the numbers look so good, but why those numbers are only the beginning of a much larger shift in how we compute. First, let's break down the raw figures so we all have a common baseline. Anthropic disclosed an annualized revenue of $65 billion, which translates to a 38% year-over-year increase. What's striking is that $18 billion of that jump happened in just a 2-month window. The bulk of that surge can be traced to 3 distinct streams. The first, and largest, is enterprise-grade API subscriptions. Large corporations, think multinational banks, global insurers, and major e-commerce platforms, signed multi-year agreements that lock in usage at premium rates. Those contracts alone contributed roughly $10 billion to the new revenue. The second stream comes from vertical-specific solutions. Anthropic packaged Claude 3 into tailored products for finance, healthcare, and legal sectors, each of which commands higher per-token pricing because of the added compliance and safety layers. That vertical push added about $5 billion. Finally, strategic partnerships with hyperscale cloud providers generated another $3 billion through revenue-sharing deals that embed Anthropic's models as default services in existing cloud marketplaces. By diversifying across APIs, vertical solutions, and partnership channels, Anthropic has insulated itself from reliance on any single customer segment, creating a revenue profile that feels more like a stable utility than a speculative startup. Why did all of this happen now, and not a year earlier? A perfect storm of market forces converged to make Anthropic's growth not just possible, but inevitable. The first catalyst was model maturity. The launch of Claude 3 brought a dramatic increase in context length, better grounding in factual data, and a safety alignment that reduced the risk of hallucinations. For regulated industries that had been skittish about deploying large language models, think a hospital's diagnostic assistant or a law firm's contract analysis tool, those improvements removed a major barrier. The second catalyst was enterprise trust. Anthropic invested heavily in interpretability tools and ran rigorous red team testing that produced transparent safety reports. Compliance officers, who are often the gatekeepers for AI adoption in Fortune 500 companies, finally had a model they could audit and trust. Third, Anthropic introduced tiered pricing that rewards higher token volumes with lower marginal costs. In practice, a startup experimenting with a few thousand tokens a month pays a higher per-token rate, while a multinational that processes billions of tokens sees the price drop dramatically. That elasticity opened the floodgates for both exploratory R&D and production-grade workloads. Finally, recent joint go-to-market initiatives with major hyperscalers made it almost frictionless for customers to spin up an Anthropic model alongside their existing cloud resources. A single click in a cloud console could provision Claude 3, attach it to a data pipeline, and start processing real-time transactions within minutes. Those strategic moves turned Anthropic from a niche research lab into a full-blown commercial AI provider capable of moving billions of dollars of workload each quarter. But here's the part most people get wrong. The surge in revenue doesn't mean the market is moving toward a single, monolithic AI provider that will own every inference request forever. In reality, the explosion in token consumption creates a massive demand for compute that no single data center can satisfy efficiently. This is where the tension between centralized power and distributed opportunity becomes crystal clear. On one side you have the centralized giants, Anthropic, OpenAI, Google, who own both the intellectual property and the massive, purpose-built compute farms that can train and serve the largest models. Their advantage lies in economies of scale, integrated safety tooling, and a direct line to the customer for support and compliance. Customers are willing to pay a premium for that reliability and accountability, which is exactly why Anthropic's enterprise contracts are so lucrative. On the other side sits the distributed inference model, which is still in its infancy but already showing the kind of disruptive potential that reshaped the internet decades ago. The sheer volume of tokens being processed, think billions of queries per day across chatbots, recommendation engines, and internal analytics, means that even a modest reduction in per-token cost can translate into hundreds of millions of dollars in savings for a large enterprise. Decentralized networks can tap into idle GPU capacity spread across the globe, data centers with spare compute, university clusters, even high-end gaming rigs that sit idle overnight. By routing inference jobs to the cheapest, lowest latency nodes, a decentralized marketplace can shave 20 to 30% off the cost of each token. Moreover, because the compute is physically closer to end users, latency drops dramatically, critical for real-time applications like conversational agents that need sub-100 millisecond response times. There's also a regulatory angle. Some jurisdictions now require that data and compute remain within national borders. A distributed network can dynamically allocate workloads to nodes that satisfy those residency requirements without the need for a dedicated local data center. In short, centralized providers will continue to dominate the high-value, high-risk, high-trust segments, while decentralized inference will carve out the bulk of the traffic that needs to be cheap, fast, and compliant with local laws. That brings us to the natural complement that decentralized inference offers to Anthropic's scale. Even with the most efficient data centers, scaling compute linearly with demand quickly becomes cost-prohibitive. Imagine Anthropic processing 10 billion tokens per day. At current cloud rates, that could cost several $100 million each month. If a portion of that workload, say 30%, could be offloaded to a network of idle GPUs that are operating in regions with lower electricity costs, the overall spend drops dramatically while keeping throughput stable. In practice, a decentralized network can provide three concrete advantages. First, cost arbitrage. By routing inference jobs to locations where electricity is cheap and GPU utilization is high, the per-token price can be reduced by a fifth to a third. Second, latency reduction. Edge nodes placed in regional internet exchange points cut round-trip times, delivering faster responses for users in Europe, Asia, or Africa. Third, regulatory flexibility. A distributed architecture can meet data residency mandates without the need for each cloud provider to build a new data center in every country. For model providers like Anthropic, Partnering with a decentralized inference layer lets them focus on research, safety, and model improvements while outsourcing the heavy lifting of scaling compute, a division of labor that mirrors how content delivery networks offload static assets from web servers. This is exactly where ChainMind steps onto the stage. We built a decentralized inference network on the premise that AI compute should be as open and competitive as the internet itself. Our platform aggregates spare GPU cycles from a wide variety of sources, large data centers that have unused capacity during off-peak hours, research labs that run batch jobs at night, even high-performance gaming rigs that sit idle when the user isn't playing. Those cycles are tokenized and offered on a marketplace where model owners can purchase compute on a per-token basis. In the context of Anthropic's revenue surge, ChainMind offers 3 immediate benefits. First, scalable elasticity. As Anthropic's token demand spikes, our network automatically provisions additional nodes, ensuring that throughput remains consistent without the need for massive capital investment in new hardware. Second, transparent pricing. Every token processed is recorded on a blockchain ledger through smart contracts, creating an auditable, tamper-proof record of usage and cost. Third, security guarantees. We use encrypted model execution and hardware root of trust attestation so that proprietary weights stay private and user data never leaves the node in an unprotected form. We've already put that theory to the test. In a recent proof of concept with a leading global financial institution, the client used Claude 3 to run risk analysis models that required near real-time inference on massive data streams. By offloading roughly 40% of the inference workload to ChainMind's edge nodes, the institution achieved a 22% reduction in compute spend while meeting stringent latency service level agreements. The client also reported that the distributed architecture simplified compliance with European data residency rules because the inference jobs were executed on nodes physically located within the EU. That example illustrates how a decentralized network can be a cost-effective, compliant, and high-performance complement to a centralized model provider. Of course, the path forward isn't without hurdles. Token economics must be carefully designed so that GPU owners receive a fair reward for their idle cycles while model providers keep costs predictable. Dynamic pricing algorithms that react to supply-demand fluctuations are essential, and we're actively experimenting with machine learning-driven market makers that balance those forces in real time. Quality of service is another challenge. Not every GPU is created equal. To ensure consistent performance across a heterogeneous network, we've built a robust benchmarking framework and a reputation system that surfaces the most reliable nodes to high-value customers. Regulatory compliance adds another layer of complexity. Distributed compute means data can cross many jurisdictions, so we're integrating chains of verifiable attestations that prove where and how each inference was executed, satisfying auditors and regulators alike. Finally, interoperability standards are still emerging. As more model owners explore decentralized inference, common APIs and security protocols will be needed to avoid vendor lock-in and simplify integration. ChainMind is contributing to open-source initiatives that define those standards and collaborating with industry consortia to shape policy frameworks that recognize decentralized compute as a legitimate service class. Looking ahead, the most plausible scenario is a balanced AI ecosystem where centralized titans and decentralized nodes coexist symbiotically. Centralized labs will keep pushing the frontier, building larger, safer, more capable models, while decentralized inference platforms will democratize access to those models, lowering barriers for startups, regional businesses, and developers in emerging markets. Hybrid contracts will become the norm. A portion of an enterprise's inference workload runs on a traditional cloud provider for mission-critical, high-security tasks, while the remainder flows through a decentralized marketplace to capture cost savings and latency gains. That hybrid approach mirrors the evolution of the Internet itself, where content originates from a few major publishers but is delivered globally by a mesh of CDN nodes, ISPs, and edge servers. Anthropic's $65 billion milestone is both a validation of market appetite for high-quality, enterprise-ready